everyone. Welcome to the December 2021 virtual UARC meeting. We have with us the usual people, of which one of them is not Morris. You're rather unusual. Say something, Morris.
Something, Morris.
Good.
Just want to welcome everybody to the meeting, and we are going to do an election here, and Clint will explain what has to happen on that.
So if you look on the YouTube chat, you will see URL to a Survey Monkey. Please vote for two people on that list for program chair, and the voting will close at 8:30 p.m. Please vote only if you're a UARC member. We can probably tell if you're not. And we will announce the results after voting completes. So please do that. I will send that link another time or two while we're in the middle of the meeting, just for people who sign on and may have missed it. So Morris, back to you for telling us about classes and whatnot.
Whatnot. Well, first off, we will be teaching online again the technician and general classes. The technician classes will be on Monday evenings for 2 hours, starting on January 17th, and they will run for about 9 weeks. The general class will be on Wednesday evenings, starting at 7 o'clock, starting January 19th. We will attempt to teach an extra class this year on Tuesday evenings at Ron Spears, K7RLS, at his home. He has very limited space. He has room for maybe 6 people. So if you are wanting to get to the take your extra class, please contact me sooner than later, because we will cut off when we reach the maximum people that he's willing to handle. And then the last 4 weeks or so, 5 weeks of that class, I will be teaching online. So it's a sort of a mixed bag, but that's how it's going to be. And it will be posted on the ARRL classes schedules. I think that's all I have. Back to you.
Okay. You did mention the tech in general, right?
Yes.
Okay. I was doing voting stuff, so you didn't have my full attention.
Oh, gee.
Yeah, sorry about that. But I thought I'd ask. Hey, Gordon, unmute yourself and tell people if, when they've done their studying, where they can go to find sessions online or in person.
The place to look where most of the sessions are listed is on the web at hamstudy.org/sessions. hamstudy.org/sessions. And then scroll down until you find things that are either online, in which case it doesn't really matter where they are, or things that are in person in Utah. And when you follow a link to one that looks like a usable date, it'll give you a chance to sign up and give you more information.
You might also add that you have to pay in advance now. It used to be that you could pay when you arrived to take the test, and now you're required to pay in advance, which of course means you have to have a credit card.
Right.
That's a good point.
Yeah, I guess people are more likely to show up if they have skin in the game. That's yeah. All right. Let's see. I would like to remind UARC members, of course, that the UARC has 2 remote HF stations. We have one at the cabin of Glen WA7X near Fairview, but we also have the somewhat fancier one at Leamington or near Leamington that includes 3 antennas, a G5RV, an end-fed half wave that works on 160 meters, and as of a month or so ago, a log periodic beam that's on top of the tower there at an elevation of about 85 feet or so that covers from 20 through 10 meters continuously, including the UARC bands, on a remote controlled rotator. So if you want to go there and read about what it takes to do that, I will share my screen here and show you what it looks like. So go to the UARC webpage. Remove some of these things off here. And if you go down here in the corner, it says HF remotes. Click on that, and you will see here a quick reference guide and a station manual. We strongly encourage you to read those. In fact, it's required that you read them. And then if you're a member in good standing, you can send a request to the president of UARC, which is currently Morris. Then he can help you get access to that station. So there we go.
Yeah, once you've met those requirements, send me an email. As soon as I've read your email and checked to make sure that you are a current member in good standing, I send it off to the person that that actually edits the authorization file, and he turns it around within hours. So once you get that part done, it goes very quickly.
Right. And at this point, where you have to be general or higher, even though tech can operate HF on novice bands and 10 meters, we're still limiting it to general. So, and I'm scrolling through here. You can find a link to some of the pictures of what we've been doing, and you can see some of the things we've been up to for setting this up. It took practically all summer to do this, because getting a tower on top of a tower, then getting a beam on top of a tower on top of a tower is not as easy as you might think. So it's been a lot of effort, but it seems to have paid off, and everything is working well, last I heard. So there, I will stop sharing, and we will move on. Is there any other business that we should take care of?
Let's do the election first.
Okay. Let's see. Well, I don't actually have a slate that I can put up, but I will send again in the...
There is a slate on the web page.
But does it include all 3 people?
No.
Therefore, that's the problem.
Yeah.
Okay. So if you look at your, if you look at the YouTube chat, I just sent it again. There's the URL to a SurveyMonkey page. And if you are a UARC member, please vote for 2 of the 3 people listed. The voting will close at 8:30 p.m. And I will read aloud who those people are.
Let me just say one thing. The 3 people are for program chair positions, and all of the other positions on the board, there is only 1 candidate for. And we have 2 program chairs and 3 people running for those.
Right. So the 3 candidates are Mike McAnish, KI7MTI, Jerry Brummett, WJ3RI, and Ryan McKee, KF7QGY. So vote for 2 of those 3 people. And again, the voting closes at 8:30, and the link to the survey is in the YouTube chat. I could put it on the screen, but presumably you have YouTube and can do that. It's a weird number. If you're having trouble seeing, I was going to say, if you're having trouble seeing it on the chat, use the chat to let me know, but that I just realized how silly that sounds. So that's how we'll do it for now. Anyway, Hey, Chuck, before we continue on, I take it you've been monitoring what's going on in the YouTube chat, and say hi to a few people, respond to a few questions or comments, as we usually
we
do.
have 39 people watching, and there have been no more comments since the meeting started. So just your posts about the voting and such. So
Okay.
I think we're ready to move on. So.
Okay. Well, we do. I was just scrolling back. We do see John and Susan Brewer in here, and one of the people up for election is Ryan McKee. He's there, and Meditech, who wants a Christmas scene like Tom. And let's see, KE7QAQ, Bob says hi. And that's pretty much the comments. If you have any questions during the presentation or immediately after it, we will get back to you for after the presentation. And I think unless we have something else to bring up, we are ready to throw to tonight's presenter, Paul, AE4KR. I think that's right.
That is correct.
Okay.
Well,
So-
thank you.
So you ready to do this thing, Paul?
Yes, with one caveat. I am not an expert in this topic. So, Clint, I will invite you or anyone else who has expertise beyond my own in this area to pop in if I get anything wrong or if there's anything to add that that is a glaring omission on my part.
Well, I think that the fact that you're not an expert in this topic puts you in good stead with almost everyone who will be doing this thing you're talking about. And we'll mention this thing shortly. And having somebody who's new to this represents the same point of view that somebody who might be intimidated by this survey that FCC is requiring us as amateur radios to do. So you can take it from the viewpoint of everybody else, which I think is a good thing.
Well, and that leads me into talking about how I did not prepare this. I started out preparing a formal presentation like a PowerPoint with slides and static stuff. And I thought, well, that's not going to help a lot of people. I think what would be more helpful is to go over why we're doing this in the first place and then go through the actual process. The American Radio Relay League has provided some fantastic resources on their website, which are available not only to members, but to anyone. And so I will actually go to those resources and pull them out one by one and show you how they work and show you that this is really not a terribly onerous thing for us to have to do.
Okay, don't leave us in suspense. Tell us what we're talking about.
Okay, we are talking about an FCC order that was drafted in 2019 and approved just before May 3rd of this year. And what it said is that the blanket exemptions for many amateur radio stations from having to conduct evaluations for RF exposure, which every other kind of radio has to do. We had blanket exemptions because it's almost never a problem for hams. We're going away, and that we were now going to have to do an evaluation to find out if our emissions cross the thresholds at which they might be considered dangerous to the public or to ourselves. And so there were two bits of confusion over that. One bit of confusion was that the rule was new. The rules regarding this have been around since 1997. There was a 300+ page ARRL book published to help us through them called RF Exposure and You, which probably hasn't had a whole lot of readership honestly since 1997. It's going to get a lot more now because most hams said, well, I'm not running 100 watts. And they went down the things that are exempt and said, I don't have to do the evaluation. Well, as of May 3rd of this year, any new station, and that's also defined as meaning any station that is moved or changed in a way that would change its RF emission profile, has to do the evaluation before it's put on the air. So a lot of people who half read it and thought, oh, I got 2 years to worry about this. No, if you go to, for example, if you volunteer to do public service events and you go and set up at a parade in a 10 by 10 pop-up tent with a couple of non-ham people sitting next to you, and you're going to run a 2-meter antenna, or even a handheld with a rubber duck, you now have to do an evaluation before you put that station on the air. And that sounds really onerous, but it's not. And we're going to go through some of the resources available to do it quickly. But first, I just want to talk a little bit about why we are dealing with this. Science has not identified mechanisms where the emissions that hams typically emit from their stations can cause adverse health effects. The thing that they have identified is that strong RF fields can cause heating in human tissues. And there is some research on that. There are two major problems if we get too much RF into our bodies. One is our eyes, and one is, to put it in terms that are okay for public use, male reproductive organs. The effects on that is temporary. The effect on the human eye can be permanent. It can cause cataracts and other problems. And the thing that those two parts of your body have in common are that they don't have enough blood flow to dissipate heat adequately. It has nothing to do with the size and shape of your eyeball socket, as an old ham's tail has held it, that at some frequencies you'll be a resonant cavity. It has to do with being able to dissipate that heat.
Yeah, I mean, I've heard it described that the lenses of the eye are kind of like the egg whites. If you get them too hot, they start turning milky, and that's a permanent thing. Hence the cataract part. Right.
And so I could probably make a ham radio demographic joke about the other ill effect, but I'll refrain from that here. So if that's the case, if there's not more than that science knows about, why are we dealing with this? Well, there's a couple of things. The fallout, pun intended, from the nuclear weapon era is still with us. It's been fading, but for a long time, anything to do with radiation of any kind was scary to people. It probably doesn't help that in the vernacular, putting something in the microwave is called nuking it. Not an accurate term. And even as that has died off now, there is a new issue that's bringing that into public attention, and that is the rollout of 5G. People are waking up one morning and looking out in their front yard and seeing towers that look like they're about at eye level to their second floor. And when they go before their city councils or complain to people, there's a lack of science there. And one of the things they reach for is, I don't want to get cancer. And you want to say, well, you could easily dismiss that because that's just scientifically not supported. The problem is zoning commissions, HOA boards, juries are usually not staffed by scientists. So it's a public perception thing that we are dealing with, and the FCC is dealing with in regard to this issue. So the FCC mandate and the limits apply to every radio service. There are a few things, FRS walkie-talkies, for example, low power consumer devices that go through a type acceptance type of process where it's determined in advance that if they meet the specifications of their design, they're not an issue. For every other kind of radio, including amateur radio, if it emits more than 1 milliwatt of RF power, it has to do an evaluation. Now, for manufacturers, there's a lot of engineering involved. For hams, they've made it easy. And again, the actual limits date back to 1997. So there are at least 3 ways that you can do this evaluation. We're going to touch on all of those in the next few minutes. One is a table that is on page 311 of RF exposure in U. And because the actual RF exposure limits have not changed since 1997, that table is still accurate. And I'm going to pull that up right now. So give me just a second. Let me start sharing the screen here for a moment. I'm going to go through the same process that you would go through to get this information. I have already downloaded RF exposure in U, so I will just pull that up, the page up that I'm talking about. Tell me, guys, if you can see this okay on the left, this table. Is it showing okay?
It's fine.
Okay. So this is a table which doesn't exempt you from the evaluation. This table is the evaluation. So on these frequency bands that are mentioned here in the left column, and for these antenna gains that are mentioned in the second column, at the 100 watt, 500 watt, 1000 watt, and 1500 watt levels, it shows you the distance in feet from the antenna that you need to have to be safe within the exposure limits. And you'll see it varies a lot by frequency. So CON and UNC, those refer to two different zones of interest. The controlled zone is space that you as a transmitter operator control. So in the case of, let's use the top end of 75 meters here, 4 megahertz, 0 dB gain. So that would be something a little less effective than a dipole. In the controlled zone, which is the area of your home, your yard, the area that you have control over, you can be 0.6 feet away from the antenna at 100 watts and be safe. For your neighbors next door, or for visitors in your home that you haven't explained the nature of RF risks to, at 100 watts, you could be 1.4 feet from the antenna. And there is a tighter standard for people who are in what's called the uncontrolled area. Now, why then, when we get to 10 meters, does 100 watts at 0 dB gain require 4.6 feet from the antenna in the controlled zone, or 10.5 feet in the uncontrolled zone? This gets into the mechanism of how this radiation affects us. It turns out that you and I and all of us are big sacks of salt water that are in the rough shape and size of an antenna. And at the height of the average adult, we have a tendency to resonate as a dipole at about 70 megahertz, or as a quarter wave if we're standing above ground at about 35 megahertz. And so this area around 10 meters is especially bad. And then again, up around, if we had the 4 meter band in this country, we'd have to worry, we'd probably have very similar numbers for 70 megahertz. So as frequencies approach 30 megahertz, 35 megahertz, that area, these numbers get much more restrictive because the effect of RF is much greater on your body. Your body absorbs much more energy from the RF at those frequencies. I'm going to continue down the page here a little bit. We'll get up into the VHF bands. They've readjusted the power levels here to be more typical of what we might run on the various bands. So on 6 meters, 2 meters, 220, the numbers are all the same. When we get to 70 centimeters, they start to relax again. And when we get up to 1.2 gigahertz, they get even more relaxed. And the reason for that is that despite the fact that parts of our body might be resonant at those frequencies, as the frequency goes up, our body is more and more protected by our skin. Skin effect becomes a more literal term here. So at 70 centimeters, a lot of the absorption happens on your skin and not internally in your body. So you can use this table as a very basic thing. If you want to put up say you want to put up a 6 dB gain antenna on your roof at 2 meters, you can go 2 meters, 144 over here, 6 dB gain, and you need separation of 6.6 feet for you and your family, 14.8 feet for bystanders. Well, your antenna on the roof is going to be probably at least 15 feet in the air anyway, so you're going to be good there. So that's one way you can do that evaluation. Now, the second way I want to talk about is calculations. And for that, I'm going to go to, I want you to just, if you want to do this, it's very simple. Just Google ARRL RF exposure. That will bring you, this second one down here is the general RF exposure page that the league offers. All right. And this made my job easy tonight because this is almost a meeting outline. I'm going to go through this parts of this briefly and open up some of these links and show you what's involved. So first paragraph, amateur radio, basically a safe activity. However, in recent years, there has been considerable discussion and concern about possible hazards. Notice they don't say scientific evidence. To allay such concerns, so it's about public comfort with radio around them, the FCC sets limits. If you have to do a station evaluation for one or more modes or powers, they have a couple of different ways you can do it. This worksheet that I'm going to show you now is, in my opinion, for what we're trying to accomplish, kind of overly complicated. There's instructions, and then there is a worksheet with about as much math as you'd need to do a 1040 EZ form. So you can do that, and when you get done, you have a sheet you can file in your records. But there are easier ways to do that. And in terms of filing for your records, you're not even required to keep paper copies of this on file, but the FCC does reserve the right to contact you at any time and ask you for your evaluation and how it was done. So if you're going to do it, at least save it as a PDF on a hard drive somewhere. Okay, next thing, there is RF Exposure in You is that book I just showed you that table from. And in chapter 5, there are a number of things explained about how to do it. The one thing you have to be careful with about using this book, the last update of it was 2003. So the book will mention exemptions from having to test, which are no longer valid. Those are obsolete, and the book really will have to be updated because the FCC has mandated now that that those exemptions are gone away and we have to do the evaluations for our stations. Okay, there is an FAQ, a frequently asked questions page that is laid out like this, like a standard FAQ. At the bottom of it, how to calculate whether your station operation is exempt. This table was written for engineers, basically. You could do it, but here are 3 ways you can evaluate your stations. One is, they mention an online RF safety calculator, and I'll show you that in a moment. Another way is antenna modeling. So if you have EasyNet or can use they have a link on this page to a free version that's for ARRL members. The information there will provide you with what you'll need to figure out what the field strength of your signal would be at various points in space around your station. And then there's measurements. Amateurs with calibrated equipment can make measurements. Most amateurs won't do this because, frankly, most of us don't have calibrated equipment. MFJ, Daiwa, those things are not acceptable for using that method. But you can go to that FAQ if you want to. The league also has general information on radio frequency safety, and they talk about the biological effects and potential hazards that we talked about already a little bit here. Now, this lengthy 2019 report and order explains in great detail how and why this change came into effect on May 3rd of this year. It's a pretty deep rabbit hole. The link is there if you want it. I don't think you'll find it terribly useful. Here's the most useful thing we get to. This is the RF exposure calculator. And you will love how slick this is. All right. So I ran this for several different antennas at my station and several that I was pondering. So let's talk about this. All right. So first we're going to start with power at antenna. Now, this is not the same as power out of your radio. If you're using good coax, it won't really matter. If you're using 80 feet of RG8X at 2 meters, it's going to make a pretty big difference. So I'll go through a couple of scenarios here. The first thing we need to know is how much power we're running. And the first thing I ran this for was the station I was going to set up when I was helping with coverage of the Murray 4th of July parade. So 5 watts. All right, and we get to duty cycle. How much of the time your mic button is pressed is your transmitter actually transmitting power? And if you're on single sideband, there's no carrier. So they say here that sideband with no speech processing is only about 20% of the time when it's actually transmitting at the power level that I listed in that first box. If we're using heavy speech processing, it rises to 50% as an assumption. CW has a carrier that's on all the time when that key is down, but you're sending dots and dashes with spaces in between. And so they figure about 40% of the time your key is actually down. FM and AM, 100% duty cycle. There's a carrier there all the time. Same with RTTY or FSK or any of the low power digital modes, you know, FT8, that kind of thing. If you're tuning up, I don't know anyone who would tune up for a long period of time, but if you did, that's 100%. And they say, if you don't know, say you're trying some new mode that wasn't invented when this was created, assume the worst case scenario of 100%. In the parade, I was running FM at 5 watts, so 100% duty cycle. There's a different duty cycle. How often are you keying the mic? So I was not transmitting much at all for this. I was waiting for instructions or relaying occasional messages. So transmitting for 1 minute, receiving for 10, I think is a conservative way to put that. Antenna gain. Well, there's a big question. I was using a handheld with a rubber duck. And from what I've been able to determine, the gain of the stock rubber duck that came with my handheld on 2 meters is a little less than 1 dBi. 2.15 would be a full-size dipole. So I'm going to go ahead and put 1 dBi. And I should explain the term here. dB without the I is a ratio. The small letter after it defines it as a power level. Well, actually, this is a ratio. This is a ratio too. dBi means how many dB of gain does this antenna have over something that would radiate equally in all directions, an isotropic source. If it says dBd, that means how much gain does it have over a dipole. And if this required me to specify it in dBd, I would have to put a negative number here because it's less efficient than a dipole. And the operating frequency, I'm going to put in 146.5. Include effects of ground reflections, which is this checkbox you can check or not. Usually for any kind of omnidirectional antenna, you'll want to keep it checked. This accounts for reflections off the ground or other nearby objects, which can add to the exposure that's experienced by someone near you. I don't know why they put this commercial in the middle. If you'd like to receive, get on the mailing list for updates from the FCC, but you can skip that part. So now if you hit calculate, here's what it tells me about my parade station. The minimum safe distance in feet from my antenna in any direction is about 6 inches, 0.5 feet rounding. That's for me. The minimum safe distance in an uncontrolled environment, so for the people sitting next to me in the pop-up tent at the table, is 0.8 feet. So that's going to be roughly 10 inches. And they also express it in meters. And they tell you here what the sources are. And unfortunately, in the print results page, it doesn't include the source information. But here's what I did with this after I got done and was ready to go to the parade. Print results. This will give me a preview. Unless Zoom is interfering somehow with my ability to see my print page. Okay. I'm going to stop sharing for just a moment and see if it'll work now.
Okay, while you're doing that, Richard Jorgensen asks, did he say the table is not accurate? You might clarify that what you should consider, or maybe you're going to get to that.
Okay, I probably wasn't clear. That table on page 311 that shows frequency, power, antenna gain, and distance is accurate because the actual limits have not changed since 1997. What is out of date in the book, there are other tables that show you if you don't have to do the test. And those are all gone now because we have to do the test. So the specific table for power, frequency, and gain for the antenna is still accurate.
All right. The other thing too is that the table is for very general cases too. I mean, if you can do a more detailed analysis of the type of antenna, like a beam, for example, off the back of the beam, you're probably fine, even really close on 10 or 6 meters, but in front of it, you may need to be farther away than that shows, or at least as far away as that shows. So the table necessarily simplifies things and is a more general case imaginable.
Yes, but at the same time, you can assume that it leaves in a sizable margin for error.
Right.
Which means that when it tells you have to be 4.6 feet from an antenna on 20 meters, that's pretty good news. I mean,
right, and it doesn't take into account the fact that, saying it's an antenna on your roof, an Omni antenna on your roof, you have two things: the power goes either way on an Omni, and then the fact that your roofing material and your house material probably knocks it down by at least 10 or 15 dB. So anyway, you have to consider things. And Mark Hodgen says, running 10-meter mobile at 100 watts will make it a challenge for my passengers to ride 10 feet away from the antenna, which will force them to all sit outside. Well, you covered that because you're not 100% duty cycle. Another thing I mentioned too is that in a vehicle, if it's a metal vehicle, consider it a piece like you're in a piece of waveguide. If the apertures, the windows are small compared to the wavelength, less of that energy you will get in the vehicle anyway. So that is harder to quantify.
It is, but it's not beyond our means, because the FCC has specifically said, use this method, this method, this method, or any method that's got scientific basis to it. So,
right. And plus, we have a lot of inexpensive toys like this $50 tiny spectrum analyzer. If you were to stand 10 feet away from, or 5 feet away from the vehicle as a reference and take a reading, then go inside the vehicle and try to simulate the same thing and see how much it dropped. You could also get a plausibly valid number on how much your vehicle is shielding you from site operation, or your house, or something for that matter. I mean, FCC doesn't really care how you do it as long as you do it in a manner that is plausibly accurate. And
the thing I was going to mention about that device, and I have an RF Explorer little spectrum analyzer, and even a USB dongle software-defined radio receiver. Many of those, while they're totally uncalibrated in terms of measuring millivolts per meter of field strength, are quite accurate at measuring relative changes based in dB. I have one of the RSP SDRs, and the software I found is very accurate. I actually did a test where I ran a 100-watt transmitter into a dummy load, and it showed a particular dBm level on the software. I dialed it down to 25 watts, which I think I can do pretty accurately, and it showed it was 6 dB down. And so,
if you're thinking of an RTL SDR dongle as one of the cheap things, if you turn the AGC off and run manual gain, then you get a proper relative S meter reading, with one of these things. If you run the AGC turned on, then the meetings are utterly bogus because I don't think the software calibrates it for you. So there's a bunch of ways one can get more technical. For example, if you think that this number you're getting is way too conservative, there's no reason why you can't drill down into a more specific case and do some actual measurements and take some of that fudge factor for safety out of there and to get something more specific to your situation, which may be favorable to your case.
Right, and especially if you're talking about in a mobile, because one of the things that has changed is that under the 1997 rules, mobiles didn't have to be evaluated, or almost no mobiles had to be evaluated. Under the new rules, they do. So do handhelds. And we're going to touch on that later because handhelds, believe it or not, compared to a 1500 watt RTTY station with an antenna at 20 feet, a handheld actually exceeds the limits where the legal limit HF station does not. Well, I am not.
Sounds like a cigarette where it's dangerous if used in the manner actually intended.
Yes, there you go. There you go. Okay, well, I'm going to be unable to print this for some reason, but if you hit print results and you're not on a Zoom session, it will actually pull up I'm in Windows 10. It'll be similar in some other operating systems where you can see a preview before you print it. And if you look at that, you'll see that the top 2/3 of the page have exactly what you have filled in here. These parameters. So frequency, power, duty cycle.
We're not seeing your page yet.
Sorry, I forgot to reshare. Okay. All right. So you should be seeing it now. Okay, so all this stuff that you filled in here will appear, minus this little section that's an ad for getting on the mailing list. It'll show you results for a controlled environment, results for an uncontrolled environment. It will not show you the calculation sources paragraphs. However, it will leave the bottom third of the page blank. And so what I did for the parade is I wrote, and it will put a date stamp at the top. And what I did for the Murray parade was I wrote down 2021 Murray parade. It was on July 3rd. And just a couple of brief notes about my setup. Yaesu FT50, OEM rubber duck antenna, 5 watts. And I took that and I tucked it away and put it in the same folder. It was actually a skinny 3-ring binder that had the instructions for the assignment to do the work on the parade route. So that is a really slick way to go if you want to have that with you. And imagine not just a parade. Let's do an HF station here. Okay, let's talk about power at antenna since we're going here. I'm going to go back for a moment. All right. Let me go back even. Okay, that's the safe activity. Let me go to the instructions for the calculator. So power at the antenna. Why is that not the same power that's coming out of your radio? It's explained here. At VHF and UHF, feed line loss can be significant. Here's that example. 80 feet of RG8X with an SWR of 1.4 to 1. 46 watts of that actually reaches the antenna. So here is a coax loss calculator. It's linked right from the site. And I apologize, this is going to be kind of squint print here. Let me zoom it just a bit. All right, so this has a bunch of different representative types of coax. and it's got Belden or times microwave or whatever, Tandy, Wireman, whatever. And then at the right, it's got the generic number of the type of coax. So let's use RG8X at HF. And here's how we do that. We go down to the calculator itself. So I'm going to put in RG8X, which is something that a lot of people use now. Let's say it's an HF antenna, you need 50 feet. Let's say we're talking about, let's try 40 meters. 7 megahertz, SWR of 1.3, power 100 watts, and calculate. Okay, so the loss in that coax at a 1-to-1 SWR, a perfect SWR, would be not quite 0.4 of a dB, so minimal because of the lower frequency compared to the example they had. The SWR loss adds 0.012, so not a whole lot. So that's our total loss in dB, and our total power reaching the antenna is 91.456. So in general, if you're talking about HF and any kind of reasonable coax or reasonable loss feed line, at HF, there's going to be very little loss, and you can skip that step if you want and just put whatever your output power is. If you're at VHF, it makes a huge difference. Let's use that same coax at 146 megahertz. And let's say you've got a Kenwood TM71 and you're running it hard at 50 watts here. If we calculate this, you now have 50 feet of RG8X at 146 with a 1.3 SWR. You have about 31 watts reaching the antenna. So if you're anywhere above HF, do go through this because it will make a big difference. If you go up to 70 centimeters, you've got less than a watt coming out the other end. So, and your SWR will probably look fantastic because when you have very lossy coax, it hides.
You did the wrong thing. You set line length to 440, not the frequency.
Well, yeah, that'll do it too. All right, 50 feet. This is still going to be ugly, but not that ugly. Thank you, Clint. Okay, so 19 watts. Not quite as ugly, but it's almost, and now let's replace this with good coax. Let's use, a lot of people like LMR 400 for runs of this length on that band. Still not great, but a lot better. So the coax will make a big difference at VHF and UHF. All right, so let's go now to that. So that's how you figure out what the number is to put in the power reaching the antenna.
Now for HF, one dirty little secret is that a good antenna tuner nearly in a match will lose almost a dB or 20%. And if you're using an antenna tuner to match something that is not even close to 50 ohms, a lot of the antenna tuners, and especially the lower power, 300 watt or 100 watt antenna tuners, you can lose half your power in the tuner easily.
And that's very frequency dependent too. I know one fairly high end, I think it was a Dentron tuner, had an efficiency on 160 meters of under 2%. So they will make the SWR look good, but they won't necessarily make your performance much better.
Right. Not to go off on too much of a tangent. If you are if you're running 100 watts at a home station, still get the dang 1 kilowatt tuner, because you'll get a lot more power to the antenna than you would from the 100-watt tuner.
Yep. All right. So we talked about duty cycle. Now antenna gain. Antenna gain instructions at the bottom of this page. Use manufacturer's free space gain figures in dBi when available. Most manufacturers of antennas that you'll find advertised list them in dBi, but just call them dB. My assumption has to be that they're assuming you'll mistake it for dBd. dBi will make the number look much higher than dBd. It'll make it look 2.15 dB higher. But if you assume they're in dBi, then you can use that. And I'm going to take an example. Something I take out for public service events from time to time is the Diamond X50A. It's a little antenna that's about a little over 5 feet long and covers 2 meters and 70 centimeters. And here's the gain they quote. They quote 4.5 dB on 2 meters, and that's going to be dBi, and 7.2 dB on 70 centimeters. I know that on 70 centimeters, it does have some SWR. It's about 1.4. It's much closer to flat on 2 meters. So let's say 4.5 dB. All right. Now, Clint mentioned going to other sources to find more precise information that might give you a little break on that. And there is actually a published antenna pattern for this antenna. Let's look at 2 meters first. So 4.5 dB on 2 meters, 7.2 on 70 centimeters. Let me blow this up a little bit. No. Well, I don't have to do that. I can just go over here. All right. So what this chart is showing you, and I suspect this comes from actual field testing and not modeling, because it actually looks like it's incurring some effects from being offset from the mast by 1.5 inches and having the mount on one side and not the other. This is really hard to read, but these are calibrated from 0 dB at this outside ring. Let's see. So this outside ring is 0 dB. The ring that represents right under the bottom of the antenna is minus 20 dB. All right, so let's say you have this directly above your pop-up tent. You've got plus 4 dBi, and then you've got minus, well, this is actually under, and it's more like minus 16 or 17 dB. So you've actually got an antenna gain for this controlled area under the tent that's going to be more like minus 12. So we'll use minus 12 in that calculation, and it will make a dramatic difference on the reading we come up with. Now, the catch is that you really have to run a couple of different calculations at different angles based on how far away from the antenna the people standing will be. So how high you get this makes a big difference. If you can get it at 20 feet, you're going to be in an area where even people standing out here at this angle will be way, way below the limit. And even a simple ground plane made out of the old famous design made out of the ARRL handbook with 4 45-degree radials soldered onto a SO239 and then a single vertical element stuck on top of a stick of PVC pipe will have a pattern that's not quite this elongated, but will give you quite a null under here that you can use. And you can look up various different designs patterns in the ARRL antenna book. You can find them published online for some commercial products. And if you have to do it yourself, you can use EasyNet or some modeling program to do that as well. So there are a lot of things you can do that will not require you to use the worst case number. All right, so the other picture I had pulled up was I closed paint, was the one on 70 centimeters, and that's a little more elongated with a little more gain. But anyway, that's where that number comes from. And look in your manufacturer stuff. QST won't even allow them to advertise dB numbers in the magazine because they don't meet the ARRL's rigor in having accuracy. And they're a little bit shady when they don't put I after this. But anyway, that's just another thing you can do with to get more precise numbers that will let you, I don't want to say get away with more, but so they talk about those things. All right, so refine. Here are some generic examples you can use. So this quarter wave vertical, which is the ground plane we just talked about, that's made out of an SO239 that everyone's seen articles for, shows 1.5 dBi. However, if you model it and you're directly under it, that's going to be more like -10. So these are going to be real worst case numbers on the omnidirectional antennas. On the beams, they're going to be even worse than that because they're going to assume you're standing in the direction of the most gain. So 10 element Yagi on 2 meters, 15 dBi gain. That's all going out toward the horizon. So you really have to find the pattern to find out if that's applicable. A half-wave dipole, 2.15 is going to be a lot closer to a representative case in most cases because it's emitting just as much. If it's a horizontal dipole, it's emitting just as much down as it is in other directions. So just wanted to show you a couple of those resources there. And the source, Clint, is the source you mentioned before we got started with the meeting. The Radio Society of Great Britain has done a lot of modeling to come up with those numbers. All right, and the caveat: antennas with even moderate directionality may need to be evaluated in multiple directions to get a complete picture. So that's what we're talking about. So you're getting worst case if you use the numbers provided by the calculator. All right, so we're kind of getting to the end of how to use the calculator. And I'm going to go back to the calculator and let's run a couple more examples. Okay, so let's look at the log periodic out at Leamington. Power at antenna. Clint, we've got some pretty decent coax on that thing, so at HF it's probably not losing much, right? I'm going to put in this. It's got at least RG8. I'm going to put in 100 watt, or do we have a 200 watt radio out there?
It's a 100 watt radio.
Okay.
We probably have a dB.5 loss, I'm guessing.
Okay, I'm going to leave it at 100, just as worst case. Conversational SSB, there is some CW operating that goes on out there, but just for grins, we'll call it conversational sideband. So we're going to transmit for, let's assume it's casual contacts exchanging signal reports, and we're going to call it 1 minute, listening for 1 minute. Again, worst case, waiting for another station to call us or for us to call them. That Cushcraft log periodic has about 6 dB gain across its frequency range. We could call it 4.5 if we want to subtract the 1.5 dB here, but I don't want to do that. All right, operating, let's call 14.250. So we're working a Parks on the air station on 20 meters. We'll calculate. Okay, results for a controlled environment. The minimum safe distance in feet from that antenna in the controlled environment, which would basically be on the tower, is 1.4 feet. Random passersby have to stay at least 3.1 feet away from that antenna. So as you can see on HF, it's really hard to get into a situation where you would be in violation of the limits. Let's run this up. Let's suppose we get a legal limit amplifier out there.
Could I interrupt you just for a half second?
Sure, Morris.
It is time for the voting to stop. So anybody that wants to vote, do it right now. Otherwise, your vote will not count. Thank you.
Thanks, Morris.
Right. I'll 2 minutes from right now, I will disable voting.
Okay. Let's calculate it for the legal limit. And look at what came out. Wait a minute. Wait a minute. Powered antenna 1500. 1 minute, 1 minute. 6 dB. Okay. Maximum safe distance for us is 1.4 feet. 3.12. Wait a minute. That looks oddly like it didn't calculate. There we go. Okay, so now you have to stay 5.5 feet away if you're one of the people who knows the risks of exposure and is part of the operation, and a little over 12 feet away if you're a bystander. Now these numbers are at 6 dB gain, so that's right off the forward-facing end of the antenna. Nobody can be there. You can't physically get there unless you're on the tower. Well, you can't even get there on the tower. So that's and it's going to be even better at the low frequencies. It's going to be even less restrictive. If we change this to 3.6 megahertz.
Although the antenna won't work there, but so it's really, really safe.
That's true. It only works from 20 meters up, doesn't it? All right. Let's say you could find an antenna that would deliver 6 dB gain on 75 meters. That's a good trick. You've got more money than I do. All right, calculate. All right, now you need to stay 1.3 feet away from the forward-looking end of it, and 0.4 feet away from it in meters, and 3 feet away if you're in the uncontrolled environment, if you're considered in an uncontrolled environment. So HF is pretty easy. I'm going to run the handheld again, and look what happens if you're holding this next to your face. 5 watts, FM. Say your net control for a net, that 1-to-1 ratio might be about right. You're going to call for a check-in, check-ins, you're going to get a check-in. You're going to acknowledge check-ins, you're going to get more check-ins. So if you're a net control running on a handheld at, let's say, 146.5, just as a general number. How far away do you think you hold the handheld from your face, the antenna? The commercial guys who have to deal with this stuff assume it's going to be about an inch or 2.5, roughly 2.5 centimeters. Okay, so the minimum safe distance for this handheld from your face is 1.5 feet in the controlled environment, over 3 feet in the uncontrolled environment. Uh-oh.
Yeah, but you gave it 6 dB a gain for the antenna.
Very good. Let's make this something more reasonable. Actually, let's make this 0, because I think a lot of manufacturers' dual band rubber ducks are, oh, stop, okay, are actually less than a dB. All right, it's still a problem, right? That's 9 inches in the controlled environment, which is who's using it. And that's minimum safe distance of over 1.5 feet for bystanders. Okay. This looks really ominous. There is work ongoing because the guys who deal with this commercially have found out that this is not realistic. We are evaluating for the radiation field strength calculated at a distance. What the commercial guys do, who have to sell, for example, 5-watt Motorola handhelds to volunteer firemen, they actually develop sophisticated modeling. Let me drop this for a minute. Sophisticated modeling, which accounts for actual models of the human body with heating effects. So they're measuring not the exposure to the electromagnetic field, but the actual heating of the tissue is being measured. And the way they do that is by building a model of the human skull with various kinds of materials and measuring the heating that goes on in specific 1 square centimeter chunks that simulate different kinds of tissues that are found in the human body. And that's a measurement called specific absorption rate. And what they have determined, this article was published in QEX, which is the Experimenters magazine from ARRL back in July. And they went through all these different bands and they analyzed handheld radios with their rubber ducks for all these different commercial or non-ham frequencies. And then they drew inferences from to the adjacent ham bands. So this is probably the best modeling we can get of the actual effect on the human body. And what and you'll see here that at these lower frequencies where the antenna is a much shorter portion of a wavelength, it's down here. And when you get up into 70 centimeters, it's almost a full-size dipole on some of these radios. So it's up here. And on some of the higher bands, the antennas can actually have gain over a dipole. So here's what they determined from their studies of the actual heating involved of the tissues. I'm going to try to highlight this. For example, in the 2-meter band, it might be presumed from comparing it to commercial radios that a handheld operating with a power of up to 22.9 watts, which I don't think even Baofeng claims that much out of a handheld, could be used before exceeding the amateur radio limit. For 70 centimeters, that's a lot closer. 5.3 watts could be used and would just comply with the local limit, the local tissue heating limit. And so this is where we get into a gray area. And I think the study will be ongoing because obviously millions of these things are being sold and we've been using them for many decades, and we haven't grown a third eye. So they're gonna have to come up with some way. And I think that given the wording of the FCC order that says we can determine it in any scientifically reasonably plausible way, covers this as well. If we can measure the actual heating effects and bypass the amount of RF reaching the surface of our bodies completely, I think for me, I would roll the dice on that. I would think that's okay. The ARRL seems to agree with that. So let me unshare for a minute, and I just have a couple of closing comments. First of all, are there any other questions? You're muted, Clint.
Nothing so far in the chat.
Okay. The main thing I wanted to get across tonight was that I kind of went down a couple rabbit holes, but the main thing is if you go to ARRL, or if you just Google ARRL RF exposure, the first 2 links on the result page will be the calculator and the general page. And I'd encourage you to go to the general page and just read a little background on it. It's not difficult. If you use the calculator, you'll be well within safe bounds. If you want to dive deeper down the rabbit hole, you can get the antenna pattern for your antenna and maybe get a little relief and be able to run more power, the antenna closer to you if it's in the right position. But then the final question is, if you're not making the grade, what do you do about it? And there's a couple of things you can do. Obviously, you could reduce power. You could use an antenna that has a more sharply defined pattern that keeps the radiation going out away from you. You could move the antenna either farther away or higher up. In many cases will do the trick. Or just so you're centered under it. You know, if you're at that 10 by 10 pop-up tent at the parade, devise some kind of clip-on mount that puts your ground plane on one of the upper tubes of the pop-up tent and get it above all of you, and you'll almost certainly get way below the limit. You can change frequency. Maybe using 2 meters instead of 70 centimeters cuts you some slack. Or one that the ARRL doesn't mention, but what is considered the controlled area? Is there an opportunity to work with the organizers of the event to clear another 3-foot area around where you're operating? Or can you put a piece of caution tape around a couple of chairs in front of where you're operating? These are all things that you could do to mitigate some of these things. So that's about all I have tonight. If anybody has any questions you want to ask me directly, I'd refer you to the ARRL first, but if you want to ask me any questions about what I said tonight, AE4KR at ARRL.net.
We do have a question that just came in, and it's a doozy. What about a cell phone held to your ear? Is there enough RF to cause a concern? That's been the subject of many, many lawsuits and you know, everything else. And
okay, the FCC says that in their engineering documents, that because you can detect a change in tissue, such as an elevated temperature, that is not the same thing as detecting damage, and that there is no scientific evidence to suggest that there is a connection between the RF and any kind of illness or disability. So that's their answer.
right, compared to the brick phones of years ago, which ran 3 watts, most phones nowadays are barely capable of running. They don't even run a half a watt, and they also run as low. The thing to know about modern cell phones is they're legally required to run the minimum amount of possible to barely even work. I mean, that is how we can share frequencies amongst a whole bunch of different cell sites and a whole bunch of users. Because what does not work is if you have one cell phone 10 dB stronger than the other ones, that kind of breaks the way the algorithm works.
Mm-hmm.
So they all run barely above what it requires before you start turning into R2D2 on your voice.
And they know very accurately what that power level has to be because they're measuring the power level they're seeing from the cell tower and using that to determine how much power. If they've got a monster signal, they'll use a tiny little amount of power to get back to it. Right.
And the other thing too is cell phone antennas, frankly, are crap. I mean, they're terrible, terrible antennas. Your hands around them, and they're around plastic, and there's compromised antennas. They're way worse than rubber ducks as far as efficiency goes. So the other answer is that even if they were kind of dangerous, nobody would want to stop using them anyway.
That's right. That's right.
We're addicted to the things.
But, you know, and there again, the fact that has become such a thing and it has persisted for such a long period of time, to me, is a great reason to have saved that PDF. And I wish that it would have printed, but for some reason connected to Zoom, it wouldn't go to that print page. But if you use the RF calculator and print it, make some notes at the bottom of what the circumstances were and what antenna it was, and save it in your file. Imagine you want to go to your HOA. I'm going to be doing this soon. Go to your HOA board for an exemption from the rules to put up a dual band VHF UHF base station antenna on the peak of your roof. One of the first things that pops up is not the aesthetic issue, but it's the next door neighbor going, "Oh, it's going to give me cancer." And
well, it should be practical to show them that they're using their own phone as way, way more dangerous than your antenna could ever be.
That won't work in my neighborhood, Clint, because some people here, I'm in a 55 plus neighborhood where many people don't have one of those phones. But regardless, I think having done the homework before you're asked the question is evidence of diligence on your part that gives you credibility when someone has to make a decision who is not of a scientific background.
The other thing people should remember is that RF exposure is a bit of a squishy area. Being out in the sun is not a squishy area for being dangerous, because the sun puts 1 kilowatt per square meter, and someone's out there wearing no shirt and just shorts. That's about 1,000 watts of heat that's covering them, plus UV and all those other things. And
Yep.
unlike RF, UV is ionizing radiation, which is the stuff that symbol of death is associated with.
That's right. The stuff that changes the DNA in your body.
Yes, yeah, it breaks bonds and causes cancer, chemical bonds and causes cancer. RF at a frequency hams use only gets things hot. So if you're imagine taking a really hot bath, the kind of damage that kind of caused, and you'd notice if that was happening. So anyway.
All right. Well, I will go ahead and put myself on mute so you can wrap up.
Okay, thank you, Paul. And if anyone has any more questions, AE4KR at ARRL.net. Let's see, Morris, let's get you awakened.
What?
Okay. Did you see the text in the chat that I sent you?
I did.
Okay. Would you care to carry on from there?
Well, we have selected 2 new program chairs. Mike McCanish, KI7MTI, and Ryan McKee, KF7QGY.
I'll note that the voting was extremely close on 2 of the parties. By 1, it was so if you didn't vote and you could have, and you don't like the results, well, you know what they say, every vote matters.
Yeah, I was slightly disappointed in the number of people that voted, but not knowing exactly how many people are out there and how many of them were members, that's not a very useful criticism.
Right.
But anyway, congratulations to Mike and Ryan. And you will be invited to a meeting next week in which we will feed your face and the rest of your body too.
And that of your significant other if you wish to bring
That's correct.
Person. Morris will get with you on details. We'll contact those people directly.
I'm sorry, say that again.
You will contact them directly.
Right, I will contact everyone directly on that. Okay, that's all I have.
Okay. Reiterate briefly about the upcoming exams. Classes. Just briefly.
Okay, the classes will be Monday, Tuesday, and Wednesday, with technician being on Mondays, extra being on Tuesdays, and general being on Wednesdays, and that's January 17th, 18th, and 19th. Send me email at my call sign at arrl.net. That's AD7SR at arrl.net if you're interested, or you know somebody that's interested. If you know somebody that's interested, send me their name and their email address, and I'll take it from there.
And those classes, technician on the Monday.
The technician and general classes run for 2 hours. Well, all 3 of them run for 2 hours, starting at 7 o'clock, and the technician and general run for 9 weeks, and the extra runs for about 16 weeks.
And the general and tech are online, right?
That's correct.
But the extra is in person with around 6 slots available.
That's correct.
Okay. If anyone wants to know more about it, contact Morris at AD7SR Alpha Delta 7 Sierra Romeo at ARRL.net. Remember that .net part, not the .com. That won't work. All right.
.org.
Does org work?
No.
Oh, I didn't think so. All right. Well, thank you, everyone. we hope you have a nice holiday season and a happy new year.
And enjoy the snow.
Yeah, and all be safe because we want you to be around for next time. Unless there's anything else that somebody on the board wishes to bring up, we are closing the meeting. Thank you to Paul and everyone who participated and showed up. So, I was going to read a few comments here, or make a comment on a few comments. Several people thanked Paul for the presentation. Good response. And David Sauce was privy to Dr. Om Gandhi. That was his name. Om Gandhi. I remember seeing a sign on the door in the 70s at the U of U, and they did spend a lot of money and didn't find anything when they were doing tests on hazard for RF exposure, other than heating, of course. So anyway, we don't think RF is as dangerous as this might show it to be, or you might get the impression that it is, but it's better to be safe and do common sense things. So 7-3, everyone, and be safe. Bye. We're dropping the link.